Now the line accelerates because the furnace never waits. Next, we reduce everything into uniform flakes for a cleaner melt. Shredding increases surface area and stalls.
Now it's liquid aluminum.
Engineering.
That's the first reveal, but it's not finished yet.
Next, precision machining.
Now we shape it to exact dimensions, or lids won't fit, and bases won't sit flat.
Even the cleaning is engineered, because trapped chips can ruin coating. Next, surface protection.
This treatment boosts durability and that's the full journey. Subscribe for more real factory transformations.
You've never seen aluminum cans turn into cookware like this.
One wrong move here, and the whole batch is ruined.
From crushed cans to giant cooking pots in one modern factory run.
Most people don't know the ink and coating must be removed first, or the melt turns dirty.
If the temperature drifts even a little, the casting can fail.
Next, we pour liquid metal into a mold that weighs more than a car. And the final result ships out today. Stay with me. The most satisfying part is coming.
Welcome inside a high-tech US casting plant built for recycled aluminum. Here, safety isn't optional. Molten aluminum has zero forgiveness.
Every step is controlled because one mistake can stop the line. The plant starts like a chain reaction, and it won't wait for anyone.
Today, you'll see aluminum cans melted down and reborn as giant cooking pots, step by step.
If the safety system fails, the process doesn't run. Next, raw cans arrive. Weight, batch ID, and traceability, because one bad load contaminates everything. It starts with one thing: aluminum beverage can bales by the thousands.
Next stop, sorting. If steel sneaks in, the melt quality drops fast.
Aluminum moves differently. This machine proves it in real time. Clean stream locked. Next, we shred it for controlled melting. This is where clean aluminum is protected before it touches the furnace.
If contamination slips through, the pot casting can crack later.
This tiny sample decides the fate of thousands of pounds of metal.
Now the line accelerates because the furnace never waits. Staging matters. Mix batches wrong, and you lose consistency. Every bale has a history. That's how the factory stays predictable. Next, we reduce everything into uniform flakes for a cleaner melt. Shredding increases surface area, but it can also increase oxidation if done wrong. These flakes look small, but they decide melt yield and purity. Next, the coatings get removed before the furnace sees them.
This step burns off ink and lacquer without destroying the aluminum.
If coating stays on, it contaminates the melt and weakens castings. Temperature is the gatekeeper. Too hot, you lose metal. Too cold, you keep contamination.
This factory captures fumes and dust. Waste handling is part of the process.
The coating becomes controlled waste. The aluminum moves on. If furnace timing is wrong, you waste energy and lose yield.
Next, the furnace. This is where everything becomes liquid metal.
Next, we clean the melt, or the pots won't survive real heat. This moment is controlled. One jam, and production stalls.
Now it's liquid aluminum. But liquid doesn't mean clean.
That thin skin on top, that's where defects begin. If dross stays in, it turns into weak spots inside the pot walls. Next step, refining.
Refining begins with controlled chemistry. Too much flux, you lose metal. This pulls impurities together so they can be removed.
Next, degassing, because trapped gas becomes bubbles inside the cast pot.
Degassing strips dissolved hydrogen out of the melt. Skip this, and castings blister.
Those bubbles aren't noise. They're the difference between strong and fragile.
Filtration catches inclusions before they become cracks. Next, alloy control. If inclusions pass, the pot can leak under heat. Cookware needs the right alloy. Wrong mix, and the pot warps. Next, precision monitoring. Now we hold it steady. Casting hates surprises.
This is the human decision moment. One adjustment saves the entire run.
A perfect melt still fails if the mold isn't ready.
Too hot, you lose metal. Too cool, the mold won't fill. Next, mold prep.
Vents matter. If air can't escape, metal can't take its place. Next, the pour. This is the point of no return.
If the pour is off by seconds, you get voids, weak spots, rejects.
This is the transformation. Cans become a single solid form. Next, cooling and release. If we rush it, the pot can crack before it's born.
Cooling is not waiting. It's controlled engineering.
That's the first reveal, but it's not finished yet.
Every sharp edge here becomes a safety hazard until it's machined off.
If the cut is wrong, the pot becomes scrap again. Next, precision machining.
Now we shape it to exact dimensions, or lids won't fit, and bases won't sit flat.
This is where recycled starts looking premium. Even the cleaning is engineered, because trapped chips can ruin coating. Next, surface protection.
This treatment boosts durability and corrosion resistance. Skip it, and the pot ages fast.
Perfect finish is visual proof of perfect process.
Next, assembly and packaging. This is where speed meets perfection.
If this joint fails, the pot becomes dangerous.
A giant pot isn't complete until it's safe to lift under real weight. Next, inspection, because speed without checks is how defects escape.
Now it moves like clockwork. Every pot, same protection, same flow.
Traceability again. If a problem appears later, they can track it back fast.
Next, lab-grade quality checks before anything leaves the building. One misstack and the whole load gets rejected. QC is next because trust is manufactured here. Next, the proof test. Pass or fail.
Every pot gets inspected. One scratch can mean a reject.
Thickness and flatness decide performance. If it's off, it won't cook evenly.
This is the final gate. Pass, and it ships. Fail, and it go back to scrap. Next, distribution.
From waste aluminum cans to finished cookware, now it heads out.
And that's the full journey. Subscribe for more real factory transformations.